day, grade 8 learners. In this video, you are going to learn about operations on rational algebraic expressions. Now, we will learn about the final lesson in Module 5. Lesson 5, Simplifying Complex Rational Algebraic Expressions. I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of simplifying complex rational algebraic expressions and simplify complex rational algebraic expressions. What's in? Let's take a review about complex fractions. So what are complex fractions? These are fractions in which the denominator and numerator or both contain fractions. Now let's review simplifying complex fractions. So we have here number 1, 1/2 plus 4/3 divided by 1 minus 2/3. So the bar between the fraction represents division. So the first thing that we are going to do in simplifying fractions is to evaluate the numerator first by finding the LCM. So in this equation, 1/2 plus 4/3 is our numerator. And 1 minus 2/3 is our denominator. So let's evaluate this expression first. So in getting the least common multiple or LCM of the denominator 2 and 3, we just have to list the multiples of 2 and 3 and then get the least common multiple. Take note that we only get the LCM if the denominator is different or dissimilar. So in this case, the least common multiple for 2 and 3 is equal to 6. So the LCD of the numerator is equal to 6. And this time, let's evaluate. So we have to divide 6 by the denominator 2. So we got 3 and then multiply by the numerator 1. So that's why we got here 3. Next is we divide 6 to the denominator 3. So we got 2 multiply to the numerator 4. And the answer is 8. So we have 3 plus 8 over 6 as the numerator, or simply 11 over 6. And the next step that we are going to do is to evaluate the denominator by finding the LCM, or the least common multiple. So just take note that any whole number has a denominator of 1. So we need to get the LCM of 1 and 3. So the LCM of the denominator 1 minus 2/3 is equal to 3. Now let's evaluate. Divide 3 by the denominator 1 of the whole number, and the answer is 3, and multiply to 1, so the answer is still 3. Next is to divide 3 to the denominator 3, the answer is 1, and multiply by 2 in the numerator, the answer is 2. And just copy the operation used, which is subtraction. So we have here the simplified form for 3 minus 2 over 3 is equal to 1 over 3. So we have here 11 over 6 divided by 1 over 3. We have now 11 over 6 or 11/6 divided by 1/3. And as a rule in dividing fractions, we need to multiply the first fraction, the 11 over 6, to the reciprocal of the second fraction, which is 1 over 3 or 1/3. So we will be able to get 11 over 6 times 3 over 1, which will be equal to 11 times 3 is equal to 33, and 6 times 1 is equal to 6. And do not forget to always express your answer to its simplest form. So can we still simplify 33 over 6? Yes, and to simplify, we have 33 over 6 divided by the GCF 3 for both numerator and the denominator. So we got the simplified expression 11 over 2. So that's for number 1. Now let's proceed to number 2. We have here 1/2 plus 5/4 over or divided by 4 over 2 minus 2 over 3. So following the steps in number 1, you have to evaluate first our numerator and then the denominator. So let's have first our numerator. So get the multiples of the denominator of this fraction in the numerator, 2 and 4. And the least common multiple is equal to 8. Then divide 8 by 2. So we got 4 and multiply to the numerator, which is 1. So we got 4 times 1 is equal to 4. This time, divide 8 by 4. So 8 divided by 4 is equal to, then multiply to the numerator 5. So you got the answer 10. So let's not simplify yet. So let's evaluate first. Let's evaluate next our denominator. So we have here 4 over 2 minus 2 over 3. The least common multiple is 6. And then divide 6 to 2. So we got here 3 multiplied by 4 is equal to 12. Next is divide 3 to the denominator 3. It's equal to 1, and 1 times 2 is equal to 2. So we got here 12 minus 4 over 6. And to simplify, we got for the numerator, we got 14 over 8 divided by 8 over 6. Now, we will rewrite 14 over 8 divided by 8 over 6 to 14 over 8 times 6 over 8, following the rule in dividing a fraction, in which we're going to divide the dividend 14 over 8 or the first fraction to the divisor, to the reciprocal of the divisor, 8 over 6 or the second fraction. Now we will evaluate applying the rule in multiplying fractions. Numerator to numerator, denominator to denominator. So we will be able to get 14 times 6 is equal to 84 over 8 times 8 is equal to 64. So we can still simplify 84 over 64 by dividing to its greatest common factor, which is 2. So we will have the simplified form, which is 21 over 8. Take note that we have to always express our answer to its simplest form. Therefore, 1/2 plus 5 over 4 divided by 4 over 2 minus 2/3 is equal to 21 over 8. What's new? Let's have this problem. 1 minus 1 over x squared divided by 1 minus 1 over x equal to x plus 1 over x. So how did we get the answer x plus 1 over x? Did we use the same method, just like simplifying complex fractions? So let's find it out together as we move on to the lesson. What is it? So what is a complex rational algebraic expression? So a while ago, you were able to learn what is a complex fraction. And this time, let's talk about complex rational algebraic expression. A complex rational algebraic expression is an expression where the numerator or denominator, or both the numerator and the denominator, are rational algebraic expressions. So how to simplify complex rational algebraic expressions? We have to remember this, that simplifying complex rational expressions is transforming it into a simple rational expression. You need all the concepts learned previously to simplify complex rational expressions. So you need to recall your knowledge in dividing rational algebraic expressions, multiplying, or even adding and subtracting similar and dissimilar rational algebraic expressions. So that's why it is called complex rational algebraic expressions. Let's have this, for example. Simplify 2 over a minus 3 over b divided by 5 over b plus 6 over a squared. So, just like simplifying complex fractions, we have to evaluate first our numerator and then followed by the denominator. So when we evaluate, we have to get the LCD of the denominator of the dissimilar fraction. So in this case, our LCD is equal to AB. And AB divided by A is equal to B times 2, which will be equal to 2B. Then just copy the operation, the subtraction operation. Then AB divided by B is equal to A times, multiply to the numerator 3. So the answer is 3A. So we have here 2B minus 3A over AB divided by 5 over B plus 6 over A squared. So after evaluating the numerator, now let's move on to the denominator. Since they have the similar denominator, so we are going to get the LCM. So in this case, our LCM is A squared times B. Then let's divide A squared B to B. So we will have A squared times 5. Yes, multiply to the numerator 5. So we got here 5A squared. Next, divide A squared B to A squared. So following the power of quotient, so The remaining answer is B. So multiply to the numerator, which is 6. So we got here 6B. So now we have our new equation, which is 2b minus 3a over ab divided by 5a squared plus 6b over a squared times b. And applying the rule in dividing rational algebraic expressions, we can rewrite our expression to 2b minus 3a over ab times a squared b over 5a squared plus 6b. So, we multiplied to the first fraction to the reciprocal of the second fraction, or the dividend to the divisor. Now, let's evaluate using the rule in multiplying rational algebraic expressions. So, numerator to numerator, so we have 2b, the quantity of 2b minus 3a times the quantity of a squared times b over ab times the quantity of 5a squared plus 6b. So, denominator to denominator. Then, following the steps, we have to cancel out common factors in the numerator and denominator. So, in this case, we can cancel out b, applying the power of quotient. Next, we can also simplify a to a squared minus a. So, it will now become a. So, our new equation will become the quantity of 2b minus 3a times a over 5a squared plus 6b. And applying the distributive property of multiplication, we can distribute a to the quantity of 2b minus 3a. Yes, so just distribute, and we will be able to get a times 2b is equal to 2ab, and a times 3a or negative 3a is equal to negative 3a squared over 5a squared plus 6b. And since we cannot cancel out anymore or simplify our new equation, our final answer is 2ab minus 3a squared over 5a squared plus 6b. Now let's try this example number 2. We have here c over c squared minus 4 minus c over c minus 2 divided by 1 plus 1 over c plus 2. So just remember our steps. We have to evaluate first the numerator of our complex rational algebraic expression. So we have here c over c squared minus 4 minus c over c minus 2 as our numerator, on 1 plus 1 over c plus 2 is our denominator. Now let's evaluate first our numerator. So we will since our denominator are not similar, so therefore we have to get their LCD. So in this case, c squared minus 4 can still be factored out using the difference of two squares. So we will be able to get c over c, the quantity of c minus 2 times the quantity of c plus 2 minus c over c minus 2 divided by 1 plus 1 over c plus 2. So in this case, our LCD is c, the quantity of c minus 2 times the quantity of c plus 2. So since these factors c minus 2 are just the same, so just copy that only one. So that's why we got only one here as our LCD, and also copy the quantity of c plus 2. And now evaluate. So the quantity of c minus 2 times the quantity of c plus 2 divided by c, the quantity of c minus 2 times the quantity of c plus 2. And that is equal to 1. then multiplied by C, so that's why we got here C. Next, so divide the quantity of C minus 2 times the quantity of C plus 2 to C minus 2. So we will cancel out. So the remaining factor will be C plus 2 times the numerator, which is C. So that's why we got here C times the quantity of C plus 2. And just don't forget to copy the operation used. So we have here C minus C times the quantity of C plus 2 over the quantity of C minus 2 times the quantity of C plus 2 divided by 1 plus 1 over C plus 2. So we're done evaluating the numerator of our complex rational algebraic expressions. And this time, we're gonna evaluate our denominator, which is 1 plus 1 over C plus 2. So we're going to get the LCD of this fraction, and we will be able to get C plus 2. And then evaluate. So just take note that every whole number has an imaginary 1 as denominator. So we will now solve C plus 2 divided by 1 in this denominator. The answer is C plus 2 times or multiply by 1 in this numerator. We will still get C plus 2. Then divide C plus 2 to C plus 2, so we will get 1. So 1 times 1 is equal to 1. So therefore, we will have C plus 2 plus 1 over C plus 2. And take note, we can still add 2 plus 1. So it will become C plus 3 over C plus 2. Now we have our new equation, C minus C times the quantity of C plus 2 over the quantity of C minus 2 times the quantity of C plus 2 divided by C plus 3 over C plus 2. Now, applying the rule in dividing rational algebraic expressions, in which you're going to you're going to multiply the first fraction, which is the dividend, to the reciprocal of the divisor, which is the second fraction. So, we will have C minus C times the quantity of C plus 2 over the quantity of C minus 2 times the quantity of C plus 2 times C plus 2 over C plus 3. Now, applying the rule in multiplying rational algebraic expressions, so multiply numerator to numerator and then denominator to denominator of the factor. So we will be able to get C minus C times the quantity of C plus 2 times the quantity of C plus 2 over the quantity of C minus 2 times the quantity of C plus 2 times the quantity of C plus 3. Next step is to cancel out the common factors in the numerator and also in the denominator. So we have here the only common factor that we have is C plus 2. So cancel that out. So our answer will now be C minus C times the quantity of C plus 2 over the quantity of C minus 2 times the quantity of C plus 3. So this is now our remaining factors. So in this case, we're going to evaluate the numerator by using the distributive property of multiplication. So we have to distribute negative c to the quantity of c plus 2. So we will be able to get c times the c minus c squared, because we will have negative c times c is equal to c squared using the product rule of exponents. And we also have negative c times 2. So we have here negative 2c. So our new equation for the numerator is c minus c squared minus 2c over the denominator, the quantity of c minus 2 times the quantity of c plus 3. And in this case, we can combine our like terms, and the similar terms in this equation for the numerator are c and negative 2c. So let's just evaluate. So we will have c minus 2c. So that's why we will be able to get negative c squared minus c over the quantity of c minus 2 times the quantity of c plus 3. Negative c squared minus c over the quantity of c minus 2 times the quantity of c plus 3 can also be written as negative c squared minus c over c squared plus c minus 6. So we just expanded our factors using the FOIL method. Therefore, the simplified form of our complex rational algebraic expression c over c squared minus 4 minus c over c minus 2 divided by 1 plus 1 over c plus 2 is equal to negative c squared minus c over the quantity of c minus 2 times the quantity of c plus 3, or we can simply write as negative c squared minus 2 over c squared plus c minus 6. And that's how we simplify complex rational algebraic expressions. And now, let's proceed to our activity. What's more? Directions. Answer the activity below to measure your understanding about the lesson. Use a separate sheet of paper for your answers. Activity 1.5. Perform the indicated operation. Express your answers in simplest form. We have here number 1. X minus 1 over x plus y minus y over x divided by x plus y plus x minus y over x plus y. Number 2, we have b over b minus 1 minus 2b over b minus 2 divided by 2b over b minus 2 minus 3b over b minus 3. Number 3, we have 1 over a minus 2 minus 3 over a minus 1 divided by 5 over a minus 2 plus 2 over a minus 1. Number 4, x minus 3 over x plus 3 minus x plus 3 over x minus 3 divided by x minus 3 over x plus 3 plus x plus 3 over x minus 3. And let's have number 5, x minus 4 plus 9 over 2x plus 3 divided by x plus 3 minus 5 over 2x plus 3. Good luck, grade 8 learners. And now, don't forget to remember that complex rational algebraic expression is an expression where the numerator or denominator, or both the numerator and the denominator, are rational algebraic expressions. Simplifying complex rational expressions is transforming it into a simple rational expression and apply all concepts learned previously to simplify complex rational expressions. So don't forget to apply your knowledge in factoring, in multiplying, dividing, adding or subtracting similar or dissimilar rational algebraic expressions. And that's all for this lesson, and I'll be leaving you with this quote: great things never came from comfort zones. So just keep challenging yourself. So I hope you learned something from the whole lessons that we have in Module 5.